Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about position time graph in a motion in a straight line. Okay, first we will discuss about if the motion is to be rest, how we can draw a position time graph. Okay, so the object is to be rest. Okay. So if the object is to be rest, how we can draw it like this? We can draw like this. Origin. The position of the body is at x0. When time t is equal to 0, the position is x0. When time t is equal to x0 itself. When 3 seconds, same itself. After t time also, the body is at the same position x0. So we can see that if the distance is here, you see that from the origin to the point, the distance is to be constant. So we can say that this body is at a rest. So this we have to draw in a position time graph. Okay. For a position time graph, the position is taken in the y-axis. This is the position and time is to be taken in the x-axis. This is the time. So always the position is to be constant when the time is to be goes on. So we can draw like this. This is the position. It is to be continuing the same position x0. What the time is to be continuous. Clear? Okay. This is the thing about it. Okay. This is the position time graph of a rest body. Okay. So position time graph of a rest body is a straight line parallel to the time axis. Okay, so straight line parallel to the time axis. Parallel to the time axis. Okay, next we will see a uniform motion. If a body is in uniform motion, how we can represent by using position time graph. Okay. Uniform motion means a body covers equal displacement in equal interval of time. That means the velocity is to be constant. Okay. So how we can draw it? You see this? This is to be the origin. Initially the body is at the position is x0 at t is equal to 0. Okay. So after t time the body is reaches to the position x. Okay. In this entire motion the velocity is to be constant. V is to be constant. Final velocity also same. Okay. How we can represent this? Okay, you see this in this motion. How I can find out the velocity? Velocity is equal to displacement divided by time. What is displacement? Final position minus initial position divided by time. That is this. Okay. So from this Vt is equal to what you will get? X minus x0 you will get. Okay. What is x? Final position. What is x0? Initial position. From this x0 will come this side. So what is x? X is equal to x0 plus Vt. This I am rearranged like this. X is equal to Vt plus x0. This is the equation for a uniform motion. Okay, uniform motion. Velocity is constant. Velocity constant. Okay. This equation I was saw somewhere the similar form where that is to be an equation of a straight line. So what is the equation of a straight line? Y is equal to mx plus c. This is to be similar. Here you see that the c, the y-intercept is to be x0 and the slope is to be v, and in the y-axis is position. So I can draw a uniform motion. Position time graph is to be a straight line like this. I can draw it. Okay, straight line. was to y-intercept. What is the y-intercept? That is x0. Okay, y-intercept is to be x0. Here this is a position. This is to be a time. This is the position and this is the time. How it will become? It is a straight line. Like this you will get. Okay, this is the graph you can get. So this is to be the thing. Okay, after t time, what is the position? That is to be x. This is the position after t time. This is the t. Okay, clear. This is the uniform motion position time graph. Uniform motion position time graph is a straight line inclined by time axis. Okay. Okay, straight line inclined to time axis. Okay, if the y-intercept is 0, what about the graph? How the graph is to be? If the y-intercept is 0, that means this is a straight line parallel to the origin. Sorry, it is a straight line passing through the origin. Okay, this is the position time graph. Position time graph is a straight line passing through the origin. Like this you will get. Okay, so this is the position time graph for a uniform motion. Okay, so from this what you got? M is the slope. Okay, slope is what what we call the slope is to be velocity. So you will see the slope of a position time graph is a velocity or not. Okay. Okay, so how we can find out a slope? Slope means tan theta. Okay, if this is theta, I am taking a 2 point here. This is a 2 point I am considering. In between this, what is the slope I am going to find? Okay, if this is theta, what about this? This is a parallel line. This is a parallel line cut by a line. So this angle and this angle are same. This is to be theta. I am naming it as a triangle, that is ABC. For this triangle ABC, what about tan theta? Tan theta is equal to slope. Okay, tan theta is equal to what? Tan theta is equal to what you will get? That is equal to opposite side, that is BC divided by adjacent side, that is AB. What is the opposite side? This you got here. This is to be intersect here. So here will be x1 and it is to be x2. Okay, and here will be at x2, this time is to be t1 and x1 time is to be t1 and x2 time is to be t2. This I can write it as x2 minus x1 divided by t2 minus t1. Okay, so what is x2 minus x1? That is displacement. Displacement divided by time. Displacement divided by time. This displacement divided by time is what? Velocity. Okay, so tan theta is equal to slope is equal to velocity. So slope of a position time graph is velocity. Okay, so that means slope is how much it is to be bent. You see here inclined, how much it is to be inclined to the time axis. Okay, if the slope is to be greater, the velocity is to be greater. That means if you see a graph, this is a position time graph for a thing, one body. Position time. Okay, the first body goes to this and another second body goes to body 1 and body 2. Okay, which body have high velocity? How we can find out? You see, you have to find out the slope of the position diagram is velocity. Here you see that this is to be theta 1, this is to be theta 2. Which one is to be greater? Here you see, you can see that theta 2 is greater than theta 1. So slope of the second graph is greater than the first. So we can say that the velocity of the second body is to be more. Okay. Body 2 is larger. Okay. This. And how we can find out the velocity from the position time graph? We can take 2 points in between the position time graph and you find out the points in the y-axis and x-axis. Okay, take out the ratio. From that you will get the velocity. Clear? Okay, this is the way we can represent about a uniform motion position time graph. When next we will see about if a body is in non-uniform motion but it is a uniform accelerated motion, how we can represent the position time graph. Okay. Uniform accelerated motion. Okay, for a uniform accelerated motion, position time graph is to be used. What is meant by uniform accelerated motion? In a uniform accelerated motion means the acceleration is to be constant. Okay, A is constant, acceleration is constant. Okay, how we can represent the uniform motion? Okay, uniform motion means this is the origin. At t is equal to 0, the position is x0, the body is at here with an initial velocity u. It got an acceleration. So what happened? The body velocity changes to v. Okay, but in the entire motion, the acceleration is to be constant and the position is now will become x, and the time is to be t. Okay, so for this motion, we can represent the displacement. What is the displacement? Displacement, that is S is equal to ut plus half at square. Okay, S is what? Displacement. Displacement means final position, that is x minus initial position, that is equal to ut plus half at square. That from this what you get? What is x? X is equal to x naught plus ut plus half at square. Okay, and just rearranging, that is half at square plus ut plus x naught, that is equal to x. This equation is similar to what? Y is equal to a x square plus bx plus c. What is this equation? This is the equation of a parabola. Equation of a parabola. Okay, you just check it. These two equations are to be similar. So, uniform accelerated position time graph is a parabola. Okay, we can draw now. Okay, this is to be the thing about the big. Okay, this is the initial position, that is to be x naught. Okay, so this is the position time graph. Here you see that it is to be a uniform accelerated motion. Uniform accelerated motion means always the acceleration is constant, but the velocity will be increases. Velocity will be increases. We have to check it in this graph. The velocity is to be increases or not. How you can check it? We previously studied the position time graph. Slope is to be a velocity. So if we will find out the slope, if the slope is increasing, we can conclude it as it is a uniform accelerated motion. So I find out a point, 2 point here. This is the slope, theta 1. Here I am going to find out a 2 point. This and this. Okay, here I got theta 2. Which one is greater? Theta 2 is greater than theta 1. That means this slope is to be greater because the opposite side is greater. Here the opposite side is smaller. Okay, so you can see that the graph is to be a increasing velocity graph. So it is not a uniform motion, but the acceleration is to be constant because it is a parabola. Okay, so this is to be a what graph? It is non-uniform motion. Okay, so graph of a uniform accelerated motion graph is a parabola. Okay, parabola, uniform accelerated motion. Clear? Okay. If parabola not only like this, other way we can draw it. How? You see, if I draw a parabola like this, this is the position. This is the time. Okay? If I draw a parabola like this, what it shows? It is also a parabola. What it shows? You will see it is also a acceleration is to be constant. Okay? In this also acceleration is to be constant. Okay? But we will see the slope of this graph. What about the slope of this graph? Here is the slope is like this. Here is the slope is this. Here is theta 2. Here is theta 1. So from this, what is theta 1 is greater than theta 2. That means while time is to be increases, the velocity is decreases. Slope is decreases. Velocity decreases. So here the acceleration is constant, but it is a negative acceleration. This is a new uniform deaccelerated motion graph. Okay. So what is this graph? Uniform deceleration. Okay. This is to be a uniform deceleration graph. Okay. This is to be the position graph, time graph in a straight line motion.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.